Hey, I'm Alex Chen, software architect. We just wrapped a significant refactoring at Swain.io. This is what actually worked. So here's the thing, refactoring has a hidden cost. It's not just the complexity or the risk, it's the time you're not shipping features. And that matters more than people realize, because you're not refactoring for fun. You're doing it to gain something on the other side. Faster feature delivery, more maintainable code, less friction for the team. The whole point is to come out ahead. But every day the refactoring drags on, that advantage shrinks. At some point, the math stops working. If you're planning refactoring anyway, and most teams do, the question isn't whether to do it. It's how to do it fast enough that you get back to delivery. And that's where we stumbled early on. We treated refactoring like it was separate from velocity goals. It's not. It eats directly into what you could ship. So let me walk you through what we actually did at Swain, how we used AI as a booster, without introducing new bugs or losing confidence. We finished in a single workday. Before we dive in, just a short break for our sponsor. I hand over to Lucas.
Thank you, Alex. Quick word from this video's sponsor, our own platform, Swain.io. Most software makers are solving two problems at once: what to build next and how to keep the lights on while building it. These usually feel like separate problems. They don't have to be. Swain.io connects the two. Your community subscribes monthly. That gives you a predictable additional revenue stream. And with each subscription, they get innovation tokens they allocate to features. So the roadmap reflects where the real energy is. You don't have to choose between building sustainably and building the right things. Link is in the description. Back to Alex.
Thanks, Lucas. Let's get back to fast refactorings. Does this sound familiar? You start a refactor. Maybe it's overdue. Maybe there's deadline pressure pushing you. You move code around, extract functions, and then the doubt creeps in. Did I just break a subtle edge case somewhere? That uncertainty just sits there the whole time. Or this one. The goal is cleaner architecture, but nobody has written down what that actually means. A week in, the code is half refactored, logic split across old and new patterns. And honestly, it's harder to read than before you started. And then the time pressure closes in. The longer it takes, the heavier the questions get. At some point, you're skipping the review, cutting the tests just to get across the finish line. That's what we set out to fix. And here's what actually worked. First, automated structural rules. In our experience, refactoring toward a fuzzy goal like cleaner architecture doesn't work. What worked was refactoring toward specific mechanical rules. That's where tools like Dependency Cruiser for TypeScript came in. They encode structural rules as checkable constraints. Similar tools for other programming languages are for sure available. Here's a concrete example from our codebase. We realized our controllers were talking directly to the database. That violated our layering, so we defined one rule. Only repository files can import database modules. Controllers can't, services can't, full stop. The rule either passes or fails, no judgment calls. Here's where it gets interesting. We didn't ask Claude to refactor the whole code base at once. That's how you get hallucinated APIs and subtle logic breaks. Instead, one rule. We told Claude to fix one violation of that rule. Claude applied the change. We ran the automated check. Pass or fail, we saw it immediately. Then we iterated. Why did this work for us? We compressed the feedback loop. Issues surfaced in minutes, not in production weeks later. Second, this is the subtle one. Integration tests were green, E2E tests were green. But I still had this residual doubt. Is there something not covered? A call path nobody thought to test? That's when I started using AI agents differently. Not to write code, to describe it. I asked Claude to analyze the original code base and describe what it does in plain language, every branch of every endpoint, with all the class names and method names it touches. Then I did the same on the refactored version. Here's the key step. I then asked Claude to take both descriptions and strip out everything language specific, class names, method names, implementation details, and leave only the resulting logic. What does this code actually do at the level of behavior and data flow? Those two stripped down descriptions should be identical. At Swain, sometimes they were, and sometimes they weren't. In one case, the difference was actually an improvement, a cleaner path I hadn't consciously planned. In another, it was a bug. Caught it before it hit main. Here's what I found connecting it all. Automated tests, E2E, integration tests, architecture constraints aren't just a safety net. They're the guardrails that let AI agents work fast and stay on track. The more precise those rules and tests are, the better the output. And the before-after abstraction comparison is the last layer on top. Not a replacement for tests, an additional check. That combination is what let us finish a significant refactor in a single workday. If I were starting with a fresh code base today, I'd build these structural rules in from the beginning. Architecture rules, high E2E, and integration test coverage from day one. Then the whole refactoring wouldn't have been necessary. Because that's what caused it, honestly. Claude Code built things that slipped through my code review. I'm still not entirely sure why it got past me. What I take from that? The AI builds fast. It doesn't know which rules matter in your specific system. That's on you to define and to keep enforcing. What about you? Have you used AI for refactoring? And how did it go? What would you have done differently in my place? And if you've got a story where things went sideways in an interesting way, I'd genuinely love to hear it. Drop it in the comments.